Hello and welcome to episode 2, which is about phone interviews. Earlier today, I was getting comfortable with the time formats and got the following results while not recording. Yeah. Um, yeah. As you can see, it clearly demonstrates that phone interviews are not all that difficult. In fact, phone interviews can be even easier than online assessments, and the reasons behind are fairly prosaic. A candidate will need to explain their solutions, but not in person, which can be quite tricky for hard problems. It also means that the most important part of the phone interview is not solving problems, right? But explaining your solutions. So I would recommend dedicating a couple of hours exclusively to speaking preparation, just to make sure that you can always explain your ideas clearly. Okay, so it is also important to feel comfortable and in control of the interview. And of course, explain your thought process along the way to make sure that you are on the same page with your interviewer, right? For example, some competitive programming enthusiasts sometimes can solve a problem faster than I read the statement. But this approach will terribly backfire on a phone interview if they are unable to explain their complicated code. So it is very important to explain things. I cannot emphasize enough how important it is to explain things. I guess these are all general tips for today. But if you feel like I forgot something, comment down below. I will definitely add more tips to the next episode. And with that in mind, let's get on to the actual problems now. Now, unfortunately, as you can see, I did a bit of preparation, again, to get comfortable with the time format. And then I started explaining everything, but the original footage got lost. Don't ask me how, because it's a bit embarrassing, but let's put it this way. It got lost, okay? So today, instead of solving problem sleeve, I believe I will explain some of these solutions, like this one, right? And more on my second account. I believe we have 3 more or 2 more on the second account. So I will walk you through solutions and show an example of how you can explain solutions, all right? If you passed online assessment, then most probably you are already capable of solving easy and medium questions. And the real deal is to explain your solutions, because your solutions are worth nothing if you cannot explain how they work, okay? In the real life, I mean. So let's check out my solutions. Phone interviews often contain well-known problems. For example, we have find winner in tic-tac-toe and angle between hands of a clock. Find a winner in a tic-tac-toe game is the following problem. Let's wait until it downloads the page. Let's not wait, let's refresh. Okay, it started downloading. Maybe you know what? Maybe I can. Oh. Okay, so we got. Okay, we got my submissions from today's recording. As you can see, I was solving these problems previously, but I came up with different solutions today, a bit different. So yeah, find winner on a tic-tac-toe games is following problem. You are given a sequence of moves. Each move is encoded by row and a column in which players alternately place their signs, so crosses and zeros, or ticks and toes, I don't know. I mean, in Eastern Europe, we call this crosses and zeros, because we do, okay? Because we can. All right. So yeah, we are given a sequence of moves and we want to find the winner, or maybe there is no winner because the game is a draw, or maybe there is no winner because the game has not completed yet, so it's pending, right? Now, we are guaranteed that the sequence of moves is valid, which means the following. We can first process all the moves. And we do just this. We create a grid, which will be 3 by 3 grid. Initially, it is empty. As you can see, we create empty strings of length 3. We create 3 such strings, put them in a vector, and we get 3 by 3 grid. Then we process moves. We unpack the tuple. So move has 2 entries. First entry is a row. Second entry is the column. And then we just process them. So we also have a Boolean variable, xMove. xMove equals true if the current player plays with crosses, and false if it plays with zeros. So yeah, initially it is true because the first player goes with crosses. If it's true, then we assign the entry of the grid a row column to the cross. If it's not, then we assign to 0. And then we change. So basically, if it was true, it gets false. If it was false, it gets true. Then we do a kind of smart trick. A smart trick consists in the following. We have an ordered map, so a hash table, which maps the character the player plays with to the name of the player. So it's fairly simple. Cross maps to A, so the first player. 0, or should I say capital O, maps to B, so the second player. Now, the reason why we need this map is to not check by hand which player won. So we will check that some player won, and because of this map, we are able to do it in a loop over players. So we loop our players and their corresponding characters, and we check if this character has won, because we are guaranteed that the sequence is valid, so only one player can win. So we will hit only one of these statements. So we iterate. Oh, yeah, you are right. I guess we shall. Yeah. This looks better. Sorry. I heard some comments that code is too small. Let's make it a bit bigger. We won't be making it just too big because I sometimes write long lines, but I believe this is better than it was. Okay, so we iterate through players. Then we think, what are the possible ways to win at tic-tac-toe? The answer is simple. You have to either get one full row, one full column, or one of the diagonals, okay? So we do just this. We iterate through rows, and we check that the current row consists fully of characters. And if it does, then we can return the corresponding player, right? Very convenient usage of an ordered map to denote players and their symbols. I mean, obviously you can write characters explicitly, but it will be awful. It will get caught 2 times longer. I don't want it. Interviewer does not want it from you. They will really appreciate if you come up with some smart way to loop through players, and yeah, an ordered map allows just this. Okay, so then we do the same thing for columns. We have to be careful, right? We iterate through all rows here and stay within the same column. This way we check that this column consists entirely of the given character. If it does, then we return the corresponding player. We then check the main diagonal and the secondary diagonal, and return the corresponding player if we detect a win. Now, if we do not detect the win, it means 1 out of 2. So one possibility is that game ends in a draw, as it should, because we know that tic-tac-toe, when played optimally, should result in a draw, at least on 3x3 board, right? The other option is the game is still pending, so it has not completed. Now, how to distinguish these cases? Pretty easily. The game is a draw when nobody won. We already know that nobody won, and all the moves were made. So we have 9 moves. Now, obviously, these conditions you can put them in a loop, right? So I believe these conditions you also can put them in a loop and compactify the code a little bit, but it's fine, man. Being too explicit doesn't hurt. Okay. The reason why you would want to put these statements in a loop is if you had like 4x4 or 20x20 tic-tac-toe game. But yeah, if you have 3x3, you can write it by hand, and I believe it would be the fastest way to write it. Okay, so this code is not excellent in the regard that it does not generalize to different sizes of the board. On the other hand, you don't have to generalize, right? Question asks specifically about tic-tac-toe, and you answer specifically about tic-tac-toe. So yeah, that's it. In case you are interested, yeah, I made a wrong submission. I made a wrong submission because I'm a fool. And I forgot that std string needs size as the first element of the constructor, argument of the constructor, I should say, and character as a second element. And I misplaced them. So it still worked, but not as expected. So character got converted to integer and integer got converted to character. And it worked because constructor matched the signature, right? But it didn't work the way I expected. So yeah, yeah. I mean, we could just write something like that. But again, I was trying to go after the code that is perhaps not the most general, but the most easily generalizable. So that's why we have variable size string here. Yeah, and it works pretty fast, as it should, because obviously we are doing, I don't know how much work we are doing, but clearly constant amount if the size of the board is constant. Okay, so yeah, it is, this is it for this problem. Now, while explaining your thought process, I believe the main parts of the problem you should focus the interviewer's attention on are detecting draws and panning games, and also if you see a nice way to get rid of unnecessary if statements like define and an ordered map which maps character to the player, definitely do it. I would be impressed. This was not the first thing that I wrote. I initially wrote like 3 conditions for cross, 3 conditions for capital O. I was happy with it until I realized that, so wait a second, we can do all that much better. So yeah. I believe this is it for this problem, and let's head on to the next one. Next one is fairly standard as well. It's about the angle between hands of a clock. Now, the way I solved this problem is the following. I computed angles from 12 o'clock to both hour and minutes hands. So first angle, second angle, or should I say hour angle and minute angle? So minutes are simply 6 degrees per minute. If you take 360 degrees and divide by 60 minutes, you get 6 degrees per minute. And this is it. When you divide by 12 hours, you get 13 degrees per hour. But you got to remember that our hand moves when minutes pass, right? So we also, these 30 degrees happen in 60 minutes. So each time a minute passes, yeah, you got to try it. Each time in Africa, each time a minute passes, right? No, each minute a minute passes, right? Yeah, that's a common meme, but whatever. It means that we have 1/2 of a degree. Our hand of the clock moves 1/2 of a degree each time a minute passes. So we do exactly that. But we can get rid of this. Now, once we have 2 degrees, we then can compute 2 differences, like this and like that. Now, the way to do it is, let's take a look. One of the angles is greater, all right? If you count angles like this. If we subtract the smaller of 2 from the bigger of 2, we get first angle. So we get this difference. But maybe this is not the smallest angle, and the smallest angle is here. And I mean not specifically this example, but some other example. In this case, you can treat the smallest of 2 as if it made one entire turn and a bit more. So it will get 360 degrees plus minimum angle. And then from this, you subtract this. And you get this. And after this, you just get to select the smallest of 2 angles, just like that. For example, in some other cases, that will be the case. Okay. Don't have pictures here, but yeah. As you can see, I was solving this problem back in the day in 3 times already. Yeah, so fairly standard problem, and each time I come up with a worse solution, apparently. No, I think I come up with better and better solutions in terms of explaining, but obviously worse and worse in terms of variables used, because this is the clearest way of explaining it I've seen. but you can do it without declaring 6 double variables. Yeah, but again, phone interviews, and I really want to emphasize and focus your attention on this matter. Phone interviews are not about solving problems. Like, I did 8 phone interviews today at LeetCode. I solved every question and I have not seen a single hard problem. So again, companies ask medium and easy question. And your goal is to explain your solution, present them, basically sell yourself to the company through your solutions so that they want to have you because you are just very good at explaining things. And truly matters when you come to your workplace. You may argue like, wait a second, you do not explain things, you write code, right? When you work. No, 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 no. Potentially. When you work for some time, you go to middle developer to senior probably, and new people come to the company, and you find yourself being responsible for them. You find yourself as their chief, right? As the man in the team, right? And this is when things get tricky. Because to be a good team leader, you really need to make sure that all of your team understands really clearly their tasks and responsibilities. And in the perfect world of competitive programming, every problem has a very precise statement, very clear constraints, time constraints, memory limit even. But in the real world, this is not the case. So it really matters how good can you formulate the problem for your team. Because if you are good at it, then your team will be very productive and you will succeed as a lead engineer. Of course, maybe this is not the thing that you think about when applying for a job, but in a long-term perspective, you should definitely think about it. Sooner or later, I believe you are not trying to get a job to earn like junior salary, right? You want to grow professionally and personally. And explaining things is the first step. If the company sees a potential in you being a good leader, they will count it when making their decisions. So I really want to emphasize your attention on this matter. Okay. Yeah, again, these 3 I was solving aiming for the fastest possible solutions. So as you can see, I spent like 9, 12, 4 minutes. And these were not really interesting. Like here, I was trying to explain everything, but then footage got lost. So fortunately, you will not see me live solving problems. But it's not all that interesting now that I think about it. Like these problems are easy and medium. You can solve them yourself. And the real difference is how we present solutions. If you're able to walk your interviewers through your solution, then you are good. If you are not, if you can only write code, then you have things to work on. Okay, let's head on to my second account, I believe, because we have more problems to cover there. And I will try to put some timestamps so that you can swap slide to the interview you are interested in. You don't have to watch entire video in case you don't want to. If you want to, it's fine. If you want just to watch some specific problems, you can watch just these problems. No, I want LeetCode sign in is very strange when you have 2 accounts. Okay. We are not in a hurry. Okay, we are in the right account, I believe. Let's head on to my interview history. As you can see, I did 2 phone interviews in this account. This one was again for speed. So 7 minutes, 17 seconds here. And another set, very interesting set of 3 medium questions. Now, as you can see, I took a lot of time explaining things, but yeah, again, the footage got lost in the most embarrassing way I can think of. Let me just walk you through the solutions, because medium problems are a bit more interesting to explain, right? It will load any second now, any minute now. Okay, let's revert to our last submission, because it will be the one that we came up during the interview. The problem is validate BST. Now, the way to validate binary search tree is, of course, by taking its in-order traversal, as you can spoil by our code. So the tree, the binary tree, is a valid binary search tree if and only if its in-order traversal results in a sorted array. Now, there are no follow-ups about constant extra memory, so I decided let's just create a vector in order traversal and push back to it in a recursive function. So we pass a pointer because we are going to change this argument. We could pass the reference, but I prefer when the client code. So imagine this is not your code, but this is. So in this code, you can clearly see that in-order traversal modifies this argument because there is a reference. Because without a reference, it won't compile. So yeah, it's really nice. I believe a year ago, Google C++ code style argumented exactly that. So it said like, if the argument of a function will change, then pass a pointer to it. If it won't, pass it as a constant reference. Well, except for the primitive types when you can just pass an object and you'll be fine, because reference takes more space than an actual object. Yeah, for example, int takes obviously 4 bytes and reference is an address. You must probably have not 32, but 64 addresses today. So the address takes 8 bytes. And especially when things like alignment come in place in C++, then you can lose a couple of bytes out of nothing because you are using in reference to an integer. Okay, so don't do it when it is not necessary. So yeah, these 2 strings just create an order traversal. In order traversal is the one in which you first traverse the left subtree, then you do something with the root, in our case push back to the output, and then you traverse the right subtree. And this is as easy as it gets. Now, obviously, you can simplify it to take constant extra memory. if you check the condition of being sorted not here but here, but I wanted to show you the idea of having like basic operations, like in order traversal, and then having some complicated operations on top of them. So this is a basic programming principle, abstraction. So you know that binary search tree has an in-order traversal, and you can build things above, on top of it, right? You don't need to write another low-level in-order traversal if you have one already. And this ability to partition code into meaningful functions really helps. And phone interview is a possibility for you to showcase your skills of not only solving problems, but writing reasonable code. So applying system designs principle. Of course, there is no system design as such. It's just basic principles, good principles of programming, good practices. Yeah. Partitioning code into meaningful parts is never bad. If a part has a specific meaning, you definitely should separate it if you can. So yeah, after we got an order traversal, we just need to check that it is sorted. For that purpose, we loop through pairs of consequent elements and just check if the order is wrong in one place and the entire array is not sorted, we can return false immediately. If everywhere the order is correct, then the entire array is correct and we just return true. It's pretty simple. I believe there is no much to explain. Like, again, you can save memory if you check this condition here. I mean, suppose that you store previous value, okay? So when you call it from the left subtree, it will return the last element, and then you check it against the root. And it will get you to the constant extra memory. But let's be real, nobody cares about constant extra memory. The times at which constant extra memory algorithms were invented and were interesting are back in the days of 1980s, I believe. Something like Morris traversal is definitely from that age. So if you know them, good. If you don't know, it should not be an issue. Just say that you don't know. You heard about that traversal, but you don't remember it, and it's fine. I mean, I would not care about it as an interviewer. If you heard about something, but you're not sure that you can implement it, it's not a big deal because on the actual workplace, you will Google anyway. Go to Stack Overflow, obviously. Nobody is capable of remembering every single bit of standard library of C++ because it is just too huge. So yeah, you are not guilty in any way if you like me forget about string initialization, whatever. You can always fix it by looking it up online. So yeah, the actual problem at work will be to solve problem in general and then fix some details later. If you did a good job explaining general solutions, then your interviewer may say like, oh, okay, you understand it. There is no need to figure out the details. I believe you can do it just like that. So yeah, having a good first impression, making a good first impression on the interviewer helps you in the future. They will be more friendly, and you maybe get away with some minor issues. In case it is like not online testing environment, but let's say Google Docs, when you just write some general code instead of actually running it on some sort of machine, you can get away just with very good explanation of ideas behind the problem. So yeah, phone interview is all about showcasing your skills, your sort of soft, but not really soft skills of explaining technical details, and of course, having good object-oriented and general programming principles. These are the two main things that you should focus on. Let's head on to the next problem. Again, retrieve last submission. Here we needed to add two numbers which are represented as linked list. As you can see, it's problem number 2. Everyone solved it a million times, a bazillion times. Yeah, I had 2 submissions, and the reason is because one of them was not optimal, so I commented it out. So adding 2 integers represented as linked lists goes as follows. We create a new list. Initially, it contains 0, one node with value 0. Let me draw something about it. And if you feel comfortable, if your phone interview is actually over some sort of online environment where you can draw on the screen and you feel like it will help you explain the details, definitely do this. Like people get most of the information visually, so you definitely should do this. So we create a new list. Initially, first element has value 0, and there is no next elements. So I will define null pointer as this. I'm not sure if this is a general agreement. So yeah, if you introduce any new notation, you got to explain it. Now then we iterate through 3 lists at a time. So output and 2 inputs. If inputs have some values in them, as long as they have some values in them, right? We iterate as long as one of the input has values. If first input has values, then we add the value here. So in our case, we add 2 here, and I'm walking you through this first example. So after we add 2, we head on to the second list, and we add 5. And we also advance both of our pointers here and here. So, right, when we added 5, our value, we do not assign 5, but we add 5, so we go to 7. Then, if we have some, if we have something to carry, so if node value is huge, like suppose we got overflow, we got like 10 here, then we bring this one and carry it. Yeah, so bring it here as 1 and subtract 10 from here. So in our case, we don't have any overflow, so we just create a new node with 0. And it further points to a non-node, null pointer, right? Then we take 4, we add 4 here. So this guy gets 4, and the pointer moves. We then take this 6, add here, obviously get 10, so we will have to deal with overflow and move to the 4. 10, we look at this and we say, okay, we got a carry. We got to carry 1. So we carry this 1 from here to the new node, as simple as it gets. And it again points to null pointer. Now we add 3, we add 4, and then we hit the condition. So Current value is less than 10 because this gets to 8 after we add 3 and 4. And both nodes has advanced. They now point to the null, right? So we hit the break condition and we break just like this. Now this condition effectively ensures that we do not create extra nodes in these two lines with value of 0. Initially, I was creating extra nodes and I had to clear this mess up afterwards. In my opinion, this problem has a sort of moral side to it. So the moral is do not create necessary problems. Do not avoid doing some work here because fixing it later will take more code. Okay, so yeah. But if you don't see this way of avoiding an issue and you only see this, first write something that works and then you can optimize it in terms of runtime complexity, in terms of extra memory used, in terms of lines of code, although you not always need to optimize number of lines of code. As you can clearly see, having long variable names, node second. So we clearly see that this is a node from the second list. Head result, right? Or head first, I should say. Head first. So the head of the first list. All these variable names may seem a little bit long to type, but they just help so much in understanding it that I'm definitely a great fan of having reasonable variable names. Again, it's a good practice. I mean, I saw 3 million questions explained in full detail in 45 minutes out of 1 hour and 30 minutes. So 15 minutes per medium question. Not bad. I mean, if I were to write Olympiad style code, so some competitive, really competitive, of course, not second would be N2, right? And head first would be, I believe, just head first, H1, right? But these names are terrible at phone interviews. I'm trying to say that you got 90 minutes. 90 minutes are more than enough to solve 2 medium, 3 medium, any number of medium questions, really. Company won't have 4 questions for you, most probably. Okay? Like 2 or 3, maybe 1 easy, 1 medium, 2 easy, 1 medium, 2 medium, 1 easy, maybe even 3 medium questions. Yeah, whatever. You have just so much time, so take your time and use it to your advantage. Showcase your skills, showcase that you are capable of not only solving problems, but also writing great code that other people can understand. So whenever a new person comes to your project, your company can be sure that they will understand your code. So you will be able to give them clear instructions and they will be able to change something, modify your code, maybe add some functionality to it. So it really matters how adaptable your code is. And if you read some modern effective C++ books, I believe, or the clean code or something like that, and you may see similar tips. And surprisingly, these tips apply to interviews because it is just so much easier to work with a person who can clearly explain his thoughts, their thoughts, I should say. Because I've seen a million times people not being able to explain something that they are really good at. For example, at my university, Sometimes I have like outstanding courses. Like functional analysis class was just whoa, uh, because the professor was really good. He was clearly explaining things. He was drawing corresponding pictures, topologies, empty, open. I mean, closed, open sets, everything like that. I don't know, some embedding theorems, just really complicated stuff, really. But when you have a picture in your head, it becomes just so much simpler. And this is kind of thing you should invest your time on the interview. Because yeah, your peers will be happy to work with you if you can write code that they understand. It's a very rare thing in programming. When, let's say, I with my friends when we were writing some sort of ICPC style competitions, not very successful at this, didn't really have much time to invest in this. I guess I just participated in a couple of such events. Just on university level. Yeah, I didn't really get interested in. But me and my teammates were writing terrible code there. So it was nowhere near as nice as here, because it's all about the speed at which you type. And here it's all about the clarity of your code, of your thought process. So this is a thing I really want to put emphasis on. I mean, you will benefit so much more from having your solution clearly explained than from solving just 1,000 of problems on LeetCode. So LeetCode should really focus your attention more on explaining things. And I believe this they have a Explorer course on behavioral interview, and it's really great. It may be more useful than a couple of technical courses. And they should really encourage you to do the same thing with phone interviews and on-sites, obviously. Not necessarily online assessments. Online assessment, I would say that you just write competitive style code as fast as possible. 5 minutes out of 1 hour, okay, let's go, submit. Right? Here you can take your time. You maybe can chat with your interviewer about the company, about the things if you finish early. So yeah, use your time to your advantage. You have plenty of. I believe that if you put some time in preparation, like watch these videos, for example, or I don't know, just attempt LeetCode contests, right? Then you are clearly capable of solving these problems, especially well-known ones, right? So it's all about explaining the solutions that makes the difference between you and the person who just solves the problem. Right? They may be great if the company wants to just quickly write some code. But if the company is something like Google, they really care about sustainability of the code, how much you can adapt it in the future. So you should really showcase your skills on that matter. Yeah, definitely let me know if you have questions about this kind of things. Like maybe me solving problems is not as interesting, is not as useful, I really should say, as walking you through some other good practices. Okay. So yeah, this is it for this problem. I believe we should move on to the next one, which is another standard problem of product of array except self. So in this question, let's go. In this question, we are interested for every element of the array to compute the product of all elements except this element. So for example, let me write something down. And again, okay, you may start with writing your entire code, but then you should definitely walk your interviewers through the examples to make sure that your solution works, okay? The best way to persuade your interviewer that your solution works is to walk through an example. If they say that if they see that example is valid, if your code outputs valid answer, you're great. You're awesome. You explained everything clearly. You solved the problem. No worries about the next round. You definitely make it. Okay. So what we do here is that we create output immediately. We know the length. We can start with ones, and we start with ones because we are going to multiply, and we should start with a natural element of multiplication operation. As you know, 1 times a for every a is a. So 1 doesn't really do anything with multiplication, and this is called the natural element. Of some operation, right? So for addition, the natural element is 0. Okay, so we start with all these ones, then we walk through and we compute prefix products. So let me create variable prefix product. Initially it is 1, then we multiply it by 1. Okay, not a big deal, you say it remains 1. And then we take the result and put it here. So we multiply next entry of the output by this. You may wonder why. And the answer is quite simple. So if you take a look, this element should get this prefix product times this suffix product. So you really want to put to the next while looping forward and put to the previous when looping backward. And this is exactly what we do here and here. Let's keep walking through our example. So next we take 2. We multiply prefix product by 2. So it gets 2. And we again multiply the next value. So this should get 2 as well. Let me yes, 2. Okay. Then we take a look at the next element, right? At 3, we change our prefix product. It becomes 6. Becomes 6, and we multiply again the next element by 6. So this one gets to 6. At this point, we correctly transferred every prefix product to the corresponding element of the output. And we clearly should do the same for the suffix products. So we forget about prefix product, and we create a new variable, suffix product gets 1. And we iterate over the array backwards. So we take this 4, we multiply by 4, and we change again the previous element, because again, this should get this product and this product. We are currently processing this suffix product, so we should definitely multiply the previous element of the output. After we do it, it gets 8. And you can already see that we are kind of constructing the correct answer, but let's keep going. So next we process what? We process 3. Obviously our suffix product gets 12, right? And we multiply the previous element by 12. I believe you see where this is going, like 12, here you get 2, you get 24, right? You get 24 here, and this is exactly the expected array. So yeah, this way of constructing prefix products is not the shortest one. I really like the following. Like in C++, you can use something like std partial sum of nums begin, nums end, like I don't know, prefix products. Let's say you have a vector of prefix products of the correct length, right? And then absolutely amazing trick and shortcut std multipliers. It will like use the usual partial sum, computes prefix sums, not a big deal. You can obviously do it yourself. But std multipliers allows you to compute prefix products. Let me bring the documentation of it. Yeah, so you can, it's from header function, and you can definitely use it with some other functions. It is really useful. So yeah, you could have constructed prefix products just like that. And I really advise exploring some of recent and not really recent, I believe this has been around for a while. Why do I say I believe when I can check since C++ 14? So 6 years already, quite a long time. Right. So this is totally the way to do it, but we have a follow-up about constant space complexity. So I originally wrote this solution and I converted it to constant extra memory because here we have only 2 extra variables. So we keep the running prefix product. We overwrite the previous product by multiplying it by nums at index. So if I had no limitations on constant extra memory, then I would definitely do it with std multipliers. It is the way to do, showcasing your skills of your knowledge, I should say. Our standard library is definitely a good thing. Forgetting in what order std strings gets its constructor arguments is not the best thing, but it happens. So you gotta quickly figure it out if it happens. So yeah, but if asked about constant space complexity, yeah, just check if you need everything at the same time. If you really can avoid using multiple variables at the same time, like you don't really care about previous prefix product, once you get the next one, then you can totally overwrite it. Yeah, something like this, I believe. So yeah, I was explaining these 3 problems. I believe this time around I made it faster than 45 minutes, but the previous time I was also writing code. So yeah, I understand that this does not look impressive, but again, people are used to online assessments, right? Where we have like, I don't know, 10 minutes. We can really solve online assessment in 10 minutes. I believe if you watch the previous episode and you know how quickly we can solve, and there's no really a point of reminding you. So yeah, again, you are given 1 hour, 30 minutes for a good reason. You should use them. And not just say like, oh, okay, I got plenty of time, let me finish everything quickly and go back to my regular business, right? Because again, When you explain your solutions, you take your time, you invest your time into the interview. And it's a good sign for the company because it's the company sees a candidate who is interested, who is ready to explain their solutions, right? Who is ready to work within the team. So interviewer is basically your first teammate in the company. Make sure to make friends with him, with them. And I mean, not necessarily like hang out in the bar, right? Nothing like that. Just be open, be confident. You got plenty of time. Use it to your advantage. That's all I can say. I also done some more interviews today. I think I will post solutions to GitHub, but we will not walk through, at least not today. I mean, we have a full episode, more longer than an hour already, and I really want to make an emphasis on explaining your solutions and not on getting like sub 10 times, sub 10 minutes times. It's not what you're here for. At work, most probably you won't have like a new problem coming in every 5 minutes. It will be more like a couple of tasks per day, and you should take your time and solve them in a way that will make sure that tomorrow you don't have to worry about that. You don't have to rewrite your code from yesterday. Because if you find yourself in a situation like that, when you have to constantly rewrite previous code, it becomes impossible to work on the new code. This is not what anyone wants. So yeah. And also, I mean, like, why rush? There's no need to rush. There's need to write good code. Good code is worth so much more than fast code. Okay. I mean, once the code is reasonably fast, you should really focus on optimizing the different metrics like readability, adaptation, so it becomes easy to adapt. Yeah. And for that reason, I don't want to walk another interview because then we will just come down to simply solving problems. I mean, it's kind of entertaining, I believe, to watch somebody solving problems very quickly, but you don't really learn from it. So I really feel like I should put emphasis on the important parts. And if you want to see me solving problems live, we can definitely do it. I can do some contest walkthrough because contests are more about solving live, about speed. Obviously, it won't be like during the contest, but I can record as I solve the contest and probably release after the contest is ended some sort of editorial in case you are interested in it. Contests are a great way of learning algorithms because you are facing new. I believe I should. Oh, I can. Okay, this is the second account. We don't have any secret information here. So yeah, I can maybe start some virtual contests, solve it, record, and release the video after the contest as an editorial. Maybe it is interesting to watch. I would hope so. But really, for the matter of phone interviews, that's all I wanted to say. Maybe I forgot some obvious tips. Let me know in the comments below. I believe there will be a post on LeetCode. There will be obviously a video on YouTube. So anywhere you're comfortable with commenting, definitely comment. I hope you enjoyed and see you in the next episode. I believe it will be in around 3 days, maybe. Maybe I will find time to work on some sort of educational lecture on some sort of data structure or an algorithm. Yeah, so it will come separately from the main focus of interview preparation, which you are, of course, most interested in, which is the reason why you are here. But keep in mind that there will be some side projects. In case you have time to watch, definitely come and watch. I will do my best, and I think you want to get come online. So thank you for coming today, and see you next time.